Hello and welcome to episode 1 of Let's Code a Rogue-Lite Platformer. This is a series of videos where I'm going to be making a game pretty much from scratch using a language called Clojure. I'm not going to do too much in the way of introducing what Clojure is or how to get set up in this video because I'm going to do another video where we cover getting set up and getting started. I'm just going to dive right into writing some code, explain what I'm doing, and I'll do some live streams and Q&A afterwards to answer any questions people may have. So to get started, the first thing we are going to do is create a new Clojure project using Linigan. Linigan is the build tool for Clojure. It does all kinds of stuff like managing your libraries for you, creating projects, etc, etc. Where are we? We're already inside a project, so we want to move up. Streaming, good, the streaming folder. This is where all of the streaming stuff goes. We are going to start by start with, line new, Play-Clj. So Play-Clj is the name of the template we want to use. Play-Clj is a library which basically wraps up a Java game library called libgdx and lets you play with it inside of Clojure. Clojure and Java both run on the JVM, that's the Java Virtual Machine, which is a piece of technology which lets you run Java code, or any kind of Java bytecode in fact. So the cool thing is we can use Clojure, which is a slightly newer language. It's a functional language. It's quite productive. You can go quite quickly, but we can drive some existing Java code to make our game quite quickly. Right. So line new Play-Clj. Let's code a. Let's code a roguelite. This will take a couple of seconds because it's going to go away to the internet, pull down the template and create us a project based on that template. There we go. So let's move into that directory. Cool. So it's created us a few things. It's made us a README, it's made us an Android desktop and an iOS folder. The only folder we care about at the moment is the desktop folder. Inside we have a project.clj that tells Linigan, the build tool, how to run code, how to build our project for us. We have a resources folder which we'll worry about later, and we have source and source common. The only code we're going to care about, the only files we're going to care about for this particular video are the files inside of source common. So let's open them up and have a look. So we have one file at the moment, and it is called core.clj. It's kind of an idiom in Clojure that your main file is, or the main file of your project is called core. And this is doing a couple of things. The easiest way to show how this works is actually just to run some code. So I'm going to run the project. So this is running the blank code from scratch, and this should create us a new window. With a little label inside, and if that's worked, then we know that everything is good. Cool. So there is our game of moment. We have a hello world down in the corner. We have a window. It's not very interesting, but it works. So let's have a look at the code that was making that happen. Let's turn on the cursor line as well, so it's a bit easier to see what I'm talking about. Right. So to start with, we have a def screen. Def screen is a method. It's actually a macro inside of the Play-Clj library. We don't really have to worry about the difference between macros and methods at the moment. I'll cover them in a later video. What we do need to care about is this onShow function here. So this is a function. Fn stands for function. It takes as its arguments a screen and some entities. Entities is a list of everything that we want to draw on the screen. As we can see here, it's updating screen to have a stage renderer. Again, we don't have to worry too much about what that means. We'll cover it a bit later when we tighten up what our rendering code does. The important thing is this function returns a label. In Clojure, the last expression in a function is automatically returned for us. This label says hello world, and the text is white in color. So this onShow function is really our setup. It gets run at the start of the when we first launch the game. This is what gets run. OnRender gets run every single time we draw the screen. That's typically 60 frames a second. What we're doing when we draw the screen is we're first clearing the screen of everything, and then we are rendering the entities. So the entities is this big list of everything that we want to draw, and the contract that's going on here is that our onShow function has to return the list of entities for the first time, and then onRender will return an updated list of entities, and that's how we move things around and change the position of things. What the render function is actually doing here is it's drawing everything, then spitting out the list of the things it just drew. Finally, we have defGame at the bottom. defGame creates our game for us, simple as that. It sets the screen to main screen. Main screen is what we're calling the screen up here. So we can have more screens later on. This is useful if you want to do things like titles or option screens. For now, we're just going to worry about, nice and simple, we're going to have a screen, we're going to have a player, we're going to have some platforms eventually, we're going to worry about moving the player around, colliding with the platforms, and that's going to be it for this episode. But pardon me. That's going to be it for this episode. We're going to try and keep the code to a fairly high standard. Yeah, we're going to try and keep the code to a fairly high standard so that it's nice and easy to build on top of in future. Right, let's get started. So at the moment we have this label. The label is nice, but it's not very interesting. So let's make something a bit more interesting to draw. So defn is creating a new method for us. In fact, let's before we dive into that, let's go into our project again. So this is just another tab in my terminal. Let's do this. So this is going to start the REPL. REPL stands for read eval print loop, and basically you type a line of code, Lineagon will evaluate that line of code and then spit the result back out at you. It's a good way for prototyping and testing things, and also if we have the REPL running in the background, we can use it from Vim, which is the IDE I'm using. Again, we don't really want to worry about IDEs at the moment. Use whichever text editor you prefer. I might talk about it more in the setup video. Cool. So let's just check everything works. Plus 1, 2, 3, we get 6. Awesome. So defn will create a method for us. I'm just going to spike out some code in the REPL to kind of show people how it works if you've never seen Clojure before. So let's create a method which takes A, adds 1 to A. We need a name for our method. Let's call it add1. Sweet. And then we can say add1 to 5, and we get 6. Awesome. So the main thing to wrap your head around, if you've not used a Lisp-like language before, is that instead of writing our code like this, which you'd see in a lot of languages, we write the code like this, which is it's called Polish notation. Basically, the first argument or the first thing in your inside your brackets is the function. Everything else is the argument to that function, or other function calls. So we could do add1 to plus 1, 2, 3. What will happen here is 1, 2, 3, or plus 1, 2, 3 will be evaluated first, and add1 will be evaluated second, giving us 7. Excellent. So defn mk player x, y, w, h, and this is going to create a player object for us. So to start with, very, very simple, we're going to use something called a shape. A shape is another macro provided to us by, there we go. This brings up the documentation for the method. Yes, shape is another macro provided to us by Play-Clj. It's used for, unsurprisingly, drawing shapes onto the screen. Right. We have a shape. Shape takes some arguments. Those arguments are, we want a filled shape. We want the color to be, let's go for green. And we want the the shape itself to be a rectangle, 0, 0 width and height. Cool. So now if we replace our label down here with mkPlayer, and we know that it takes, we're going to worry about x and y in just a second. For now we're just going to worry about width and height. So let's make this 16 by 48 to start with, and then run and see what happens. There's a chance this will blow up because I've made a mistake, and that's kind of good. I want to show people mistakes as they happen and how I go about fixing them, because a big part of writing code is fixing your mistakes. If anyone tells you that it always works first time, they're lying. Cool, so we now have a green rectangle. Let's change this so that we can choose where our rectangle goes, because at the moment we're stuck down at 0, 0, which is this is 0, 0, this is plus max x plus max y. So our axes start down here. This is the x-axis, this is the y-axis. Right. So straight away we are going to sock into this shape an x value of x and a y value of y. Cool, let's talk about what's going on. So Play-Clj, when it gives you back an object or an entity, so shapes are entities, anything, pretty much anything we draw in our game is going to be an entity. When it gives you back an entity, you can add your own values to it, as though it were something called a map. A map is a data structure in Clojure. It's one of the most common data structures you use. You use it for storing keys and values. So to create an empty map, you do this. This is an empty map. To create a map with some keys and values, you do so key to value. Once we have a map, so let's define a map called myMap. Def is for defining variables. Cool, we have myMap, and we can also pull out the values using the keys. So one of the nice things, and the things you get used to in Clojure, is that these keywords are also functions which will pull out whatever value they're pointing to from maps. So every entity from Play-Clj is also a map, and you can store values inside it. Some values already have a special meaning. So x and y, Play-Clj is smart enough to know that if we have an x value and a y value, it's smart enough to draw that entity at the x and y position we pass in. So now that we've set this to x and y, let's change this to be 200, 200. Just waiting for the code to compile. Awesome. So now we have our player, and they are at position 200, 200. I should cover what a sock does very quickly. A sock is for storing new values in a map, or it's actually for creating brand new maps. So in Clojure, everything is immutable, you're strongly encouraged to write immutable code. Immutable means you can't edit it. So if I have a map, I can't change what that map is later on, but I can make a new map which looks like my old one with a couple of changes. And that's exactly what a sock does. So if we sock, we had key, let's do key 2 is value 2. We get back a new map which has 2 values instead of 1 value. It has key value and key 2 value 2. But if we look at our original map, it's still our original map. We didn't change it, and we can't change it. And the reason for that is it makes your code easier to think and reason about. When you have hundreds of these maps flying around, you don't want to be worrying about when you last changed it. Instead, you can never change things, you can only create new things. It's easier to think about that way, once you rewire your brain to think in terms of functional programming. Cool. neaten this up slightly. There we go. So we have a shape, we're associating an x and y value. That x and y value is being used to work out where we should draw the shape. All well and good. So the next thing we want to do, if this is our player, is maybe we want to move the player around, because a game where you can't move anything is kind of I guess you probably could make an interesting game where there was no player movement, but that's not the kind of game we're going to make. So the simplest kind of movement is probably falling. So let's write something that's going to make our player fall down every turn. Or every time the screen is rendered, we're going to make our player fall down slightly. And we're going to need a couple of values to let us do that in a nice way. The first value we will call gravity acceleration. And we're going to set this to minus 0.6 to start with. These values we're going to come back, we're going to tweak, we're going to change them a lot, because good platformers are all about having tight controls, and tight controls come from controlling these values so that your player jumps just the right amount, they fall at just the right speed, they land at just the right amount. Great, so that's our acceleration due to gravity. We also want our max fall speed. Our max fall speed, let's set to -4. And you might be thinking that the one thing we could do, and you would be right, is down here we could just take our player and return a new version of player. Return a new version of player with a new y value, with a y value which is the decreased, so dec will just -1 from a number, the decreased value of y of player. And we're going to map over all of our entities. We only have one entity at the moment, and that's the player. What map does is it takes a list of things, so like a list of everything we want to draw onto the screen. It will run a function for every single thing in the list and give you back a new list based on the results of that function. What this function does is it takes our player, because it's the only thing in the list, so we know that it's the player, and it associates a new y value based on the old y value. Let's run this, and actually before we run this, if all goes well, let's set this to about 700, because we want our player at the top of the screen so we have a lot of time to watch them falling down. There we go. So that's the simplest kind of a falling code we could have, but we want to do something slightly different, and the reason we're going to do that is we want more control over how our player moves. We would like them to accelerate, we don't want them to fall at a constant speed. That says max fall speed. There we go, max fall speed. So we're going to store a map of velocities on our player. So we'll have an x velocity which will start at 0 and a y velocity which will start at 0. And we're going to use our velocity values to update our positions. And what this will let us do is have the player accelerate or decelerate and change direction based on how fast they're already moving in a different direction. It's a bit more complicated, but it will let us have tighter, more finely grained controls, which is what makes a good platformer. Right. So we're actually going to pull out a new function. So we're using Clojure, and kind of the currency of Clojure is functions. Functions everywhere. We don't want to have too many data structures. Instead, we want to have lots of functions which operate on the same types of data structures. Data structures are things like maps, or arrays, or lists, or vectors. Functions are things which take those and give out a new or changed version. Or generally a new version because of the whole immutability thing, but sometimes it's easier to think of it as a change instead of a completely new value. Right, so we're going to create a new function and it's going to be called gravity. Gravity is going to take our player and it is going to, or first of all, let's just replace our code down here with a gravity function. Excellent. So because map just takes a function, we can just give it gravity because gravity is a function. And let's see if this still works. Cool, we have fooling. Exactly the same fooling as we had before. Now let's make it fancy. Let's bring out the good gravity. This is the kind of gravity that we, bring out when important people come around to visit. This isn't the nasty gravity. Right. So to start with, what we want to do is we do want to update the player's Y position, but we want to update it based on... Actually, yeah, let's first of all introduce some destructuring. So destructuring is a way of grabbing the values from inside of a map when you use that map as an argument to a function. So we want the X and the Y key and actually the velocity key from our map. Cool, sorry, just thinking for a second there. Yes, and we still want to hold on to a reference to this as player. But now we also have access to the X, Y, and velocity values from inside of player, these guys here. So let's update the Y value to be equal to the current Y value plus the Y velocity. And Y velocity is currently 0, so the player should in fact not move. Let's put the player back on the screen so we can hopefully see them not moving. Waiting for the code to compile again. Cool. There is our player. Our player is no longer moving. We've broken the gravity. Let's turn it back on. So we're going to produce or create or write or whatever a second function here called update velocity. And this is also going to take a player, but we're again going to use some destructuring to grab the values from inside of the player. If anyone has any questions, I'm going pretty fast and introducing a lot of new concepts because hopefully, rather than explaining everything, I want to address things people have specific questions about. That way it's a bit more interesting for me, it's a lot more interesting for you. So if anyone does have any questions about what I'm doing, then leave a comment, email, private message, carrier pigeon, whatever your preferred method of communication is. Very happy to hear from people and answer questions. Update velocity. Update velocity is going to, again, we're going to use a sock. We're using a sock an awful lot. It's a very useful function. Eventually we might swap our sock for something a bit more advanced, but it works for now, so if it's not broken, don't fix it. We take our player, we update the velocity value to a new velocity value. What velocity value do we want? We want to yes. Sorry, thinking and talking and typing at the same time is surprisingly tricky. Right. Let's update our velocity. So velocity is also a map, so we can associate velocity as well. Actually, we can make this clearer. Let's also introduce a let. Let is a function for introducing temporary variables just to make your code more readable, more understandable. So let's have a new velocity, and new velocity is going to be the old velocity with the y value updated to be plus the, and this is where let is really useful because we want the y velocity, so we're just going to pull out y from velocity like so. Then we're going to say the new velocity is equal to the y velocity plus gravity acceleration. Bit of auto-completion there. Then down here we just need to associate velocity to new velocity. Nice and simple. So, quick sanity check. What this is going to do is, we need to call it. So we now have two functions and we want to string them together. The way we're going to string them together is by using this guy. This is a threading macro. It's for calling lots of functions one after another that take the same arguments. Let's do a quick demo of how the threading macro works, because why not? If you want to update something a lot of times or call the same kind of function repeatedly and take the input of one function or the output of one function and use it as the input for another function, one option is to write your code like this. So empty map update A to be B. Now let's say we also want to update X to be Z. Cool. Now let's say we, you can kind of see what's happening here. We have this guy on the inside, then this guy on the outside. As soon as we have lots of values, this is very hard to read. So there's an alternative way of writing this, which looks like this. A is B, and sock X is Z. Boom, same result. So what this guy does is it will fill in the first. Notice that when we use a sock or associate here, we're missing out the first value. That's because this threading macro will fill in the first value for us. So the first argument is what you want the first value to be, or the first value you want passed to your function. So this will get passed to here, then the result of this will get passed to here. And if we had more of them, it would keep going. It will make more sense when you see it in action if it's not making sense right now. Right, so we want to map. We need to bring back our function because we're now mapping over a function. We know that we only have a player at the moment. We're going to have to change this later to pull out the player from all of the other entities, but for now we only have a player. We're going to take our player, we're going to pass our player into update velocity, then we're going to pass our player into gravity. This will take the player, pass it into this function, then pass the result of this function into this function. Excellent. Right, got a little distracted there, what were we doing? Right. So hopefully we should see our player not just fall down, but accelerate as they fall. So the further they fall, they will fall faster until they hit this max full speed here. Max full speed is my name. Alternatively, it could blow up. That's always fun. Excellent. Unable to resolve symbol new velocity in this context. Went a bit fast there, but the error was that it couldn't find the new velocity, and that's because I need to extend my let to actually contain the code I want to reference values in. So basically, my let was ending here. It needed to end down here. needed the closing bracket to be down at the bottom here, so that it also included all of this code where I'm actually using the values. Let's try again. Cool, and that actually works, but I couldn't move the window onto the screen in time fast enough. So let's try again. Eventually I will work out how to get the game to start up in my streaming window and all will be well in the world. Until that time, you know, we're just gonna have to trust that I'm fast enough. Nope, missed it again. Okay, so what I'm gonna do here is lower the full speed and lower the acceleration because I just can't move the window fast enough, which is kind of embarrassing. There we go, there's our player, and hopefully you saw at the last few seconds there we were actually accelerating. Nice. Onto my to-do list I will add fix the Windows setup. Cool. So we now have a player, that can fall down. Let's also think about left and right. Left and right we're going to handle in a very similar way. Except rather than having gravity or something constantly moving the player, the key presses from the user are going to move the player. So let's call this guy update X position. Unsurprisingly, it's going to take a player object. Keys. We're probably going to want the X value, the Y value. To start with, we're only going to want the X value. We will want the velocity, and we probably still want to refer. I generally put in the. You don't have to put in this as player at the end, but I like to put it in because it reminds me what it is I'm actually destructuring. Because you know I'll come back to this in a week's time, and I'll have forgotten everything. So, in fact, exactly the same as the function above, but for the X value. Whoop. There we go. So one thing that's worth mentioning is when I record this, I actually have music on in the background, but only I can hear it because of copyright concerns. Partly it's because it makes me speak a bit louder and makes the microphone pick up my voice better if I think I have to talk over some music, and partly I just like listening to music when I code. But very sorry I can't have it in the video. We'll try and sort something out for next time. So, update X position looks surprisingly like gravity, so let's actually change gravity's name to update Y position. Just, you know, get some symmetry going on. Update X position, update Y position. Good, good, good. So of course, currently our X velocity is 0 and it will always be 0, and so our player won't move anywhere. But before we do anything else, let's just introduce a small amount of X velocity, and this should have the effect of having the player constantly drift to one side. Okay, let's actually increase this to a value where we're likely to see the result and try again. There we see our player was ever so slightly moving. Right, let's make this a bit more let's do it properly now. So let's also pull out a, we'll call it movement, or let's call it X acceleration. So this is like our gravity, but for moving left and right. And let's have it at 0.66. I'm guessing values here. We'll come back and tighten them up later. X acceleration and max X speed. Let's make our max X speed 4. Is 4 reasonable? Maybe. We can worry about that a little later. So we have update velocity. Let's actually change this, because all this is really doing is updating our Y velocity. Let's have a new function for update X velocity. Whoop. Keys velocity as player. And in a very similar, pretty much exactly the same, but for the X value. So eventually we can probably we can do some refactoring. We can rewrite this and probably combine these into one function, or pull out some functional smarts to let us update values which look the same. But for now we're going to write it all out long form. It helps, you know, I always write my code in long form first and then go back and fix it and make it smarter afterwards. I just want to get the basics right first. So new velocity is going to be our X velocity plus, I know what we totally forgot to do. We haven't taken into account max velocity yet. We'll loop back and do that. So that was why the player was falling so quickly before. We'll introduce our max velocity in just a moment. Right, where were we? X velocity, excellent. So X velocity plus X acceleration. In fact, our new velocity, let's do it all in one go. We can do this. Condition key pressed. So key pressed is a function from Play-Clj which lets you detect if a key is pressed. Simple as that. So if the D key is pressed, then we're going to say our new velocity is going to be equal to X velocity plus, X velocity plus, so because plus is over here, X velocity plus X acceleration. If the A key is pressed, then we will minus instead. Cool, so we should be able to twitch the player left and right, but they will be falling so quickly that we can't really notice because I totally forgot to cap out the velocities and use these max values here. So let's do that. The way we're going to do that is we're going to write a new function called clamp. Clamp is a function which gets used all the time in game development, and it takes a number, it takes a max value, or takes a min value. I like writing it this way around. It takes a max value, and very simply, if the value is bigger than the max value, we're going to return the max value instead. If the number is smaller than the min value, we're going to return the min value instead. Else we are going to return the value itself. So this will clamp a number between a maximum value and a minimum value. That should be min n. Cool. So we're missing a else line from our condition, else 0. So if no buttons are pressed, we want our X velocity to be 0. We want the player to stop. At least at the moment we will. You know, eventually we might want them to skid to a halt or have them slide or something, but at the moment, if no buttons are pressed, don't move the player. Cool. And finally, we're going to use our clamp function. We are going to clamp this value. The minimum is going to be 0 in this case. The maximum is going to be max x speed. Just turn off wrapping. Makes it slightly nicer. And the same way, we're going to clamp our value here. Whoop, completely wrong button. There we go. Clamp our value, and here we want to clamp our minimum value, because we're going the other way, is going to be the minus version of our max x speed. The maximum value is going to be 0. Good. And finally, we can finish off this function by making it actually do something. We will associate player velocity as new velocity. Except, yes, this is currently just returning a number. Right, so let's pull this, what does this guy take? This guy takes some key presses. I'm working out or trying to work out if I can pull this out as a function, but I don't think I can. So we're gonna make this very ugly for a moment by saying associate velocity x with all of this crap here. There we go. So our new x value is either going to be clamped between 0 and max speed if you're going right, or clamped between min speed and 0 if you're going left. Otherwise, it's going to be 0. And let's also use our clamp function up here. And in this case, we're going to, our minimum value is going to be, what did we call it? Max full speed. And 0. Right, let's see if this works first time. It probably won't. We made a lot of changes there. You probably don't want to make that many changes and then run your code again. You always want to be, make a small change, run the code, check it works, make another small change. Yep, unable to resolve symbol update velocity in this context. Yes, that's because we changed a whole bunch of names. Update y velocity. So we probably want to put these the other way around for reasons we don't care about at the moment, but if we want to do slope detection, eventually you want to detect x before you, or update x before you update y. The advantage of using this threading macro is it's really easy to add new lines, and it should all work. Let's try again. Cool, we can move left, we can move right, or right and left, whatever. We only caught the end of that, so I will just run it again slightly to prove it does work. Move left, move right, full down. Cool. And that is pretty much it for basic movement speed. The next video I'm going to do is going to introduce the idea of platforms so we can actually land on things. Once we can land on things, we can think about how we're going to jump. I'm going to stop this one here because I think that's been about 40 minutes, which is probably, I heard the other day that 40 minutes is the longest people can comfortably concentrate for anyway. So, see you next time, hopefully. If you do have any questions, then please send them in, write them in the comments, etc. If you like or subscribe to the channel, it lets me know that you're interested, and I'll be more likely to create new content. Hooray! Thanks very much, everyone.